I'm Isaiah Yarbrough, so do preventive maintenance on an air handler. A big difference between an air handler and a gas furnace. This has electric heat. If you're in a place, live in a neighborhood that don't have propane or natural gas, this is a good alternative. They're not as common because a lot of the country, they have propane, but a lot of houses, they don't have natural gas or propane, so they have this. This is a good alternative so you can have central heat and air. Kind of same parts. So you got your blower right here. Part of this is your evaporator coil. So as you'll see, compared to this to the natural gas unit, there's no flue pipe. So no flue pipe because there's no combustible air coming out of this. It's just your heat strips that are heating the whole unit. These, you don't have to deal with carbon monoxide, which is nice. You just got a heat strip, I will say, if you're trying to have a funky smell when you first kick them on. So right here, you got an aluminum coil, condenser up top. It'll mostly either be straight AC or it'll be a heat pump. You kind of got your THV, your evaporator coil, your blower, your breakers, and kind of all this wires and stuff. Your heat strips are back behind it. The heat strips, how they work, it starts at your breaker. You want to start from your breaker going to your fusible link. And your fusible link is what goes in your heat kit, which sends power to the other side of your heat strips. So after you send power to the other side, your heat strip fusible link will go to a limit. And your limit, what it does is determine if it gets too hot and something's out of whack, then it'll shut the unit off for a safety switch. So after it goes to the high limit, it'll go to your sequencer. So after it hits your sequencer, it's kind of hard for me to show you what it does, or where it is, but after it goes to your sequencer, it'll come back to your breaker to complete one circuit. This is how we'll kind of test our heat strips, the easier way to do it. It's kind of color coordinated. There's two 60 amp breakers. I'm gonna go keep this unit on real quick, and we're gonna test these heat strips. Thermostat on, have the breakers turned off. It's gonna ramp up because of the ECM motor, no capacitor. We're just gonna wait a little bit. So sometimes they do have it on instantly. You wanna have around 20 amps. So 35, because they are joined in together, it should be around 40, but 35 with it just now turning on, it's perfectly normal. We're gonna let it run. Same with these ones. These two are joined in together. This is two separate breakers or two separate heat strips. So this is about 37, they're joined in together. Now I'm just gonna kind of check my blower amps. Amperage we're getting about 4.15. To let us know if that's within range, you go to the nameplate here from the factory. It'll let you know your fan load amp. So it's about 6.30. So you want that to be below the factory requirements. If it gets above that, that's when you know, hey, your motor's working harder than it should. But with it being below that, it's working within range. Electrical wise, more to fail on this because mostly it's all electric. So you got some stuff that can get killed. So you got fusible links that can go bad. You got your transformers over here. You got your two contactors. But for your gas one, you got more components that can fail. This is just more everything that's kind of joined in together that can kill the whole circuit with one part going bad. But with the gas one, depending on which part, it can still run. But the gas one, like you said, you got the pressure switch. If that goes bad, it'll kill the whole unit. The inducer not letting out the carbon monoxide of the flue pipe, the combustible air. They both have the pros and cons. Both of them do certain things a certain way. It just all depends where you live at and for your electric bills. I definitely recommend having a heat pump. It's way more efficient for your house, utility bill wise. And now what I'm gonna do, I'm gonna get my temperature probes here. I got one for your return and one for your supply. I'm gonna drill a hole inside to put them in the ductwork, not causing any harm to the system, just so I can get it more accurate on my wet bulb, my temperature, and what I should be reading. That's your temperature probe right there. I'll be able to read it on my Fieldpiece app here soon. After we get done working on it, we're gonna tape it up so it doesn't push any airflow out or suck any outside air in. So we got that in. I'm gonna go ahead and button these doors on real quick. So we get a more accurate temperature split difference. Now we get on our Fieldpiece app. We're gonna look at our delta T, our temperature difference. So we're pushing about 83 degree air out right now, but with it just now kicking on, we're gonna have to let it run for about 15 minutes. So right now you want temperature split with these air handlers. They can get up between 140, but another safety switch in this one, they have high limits. So if they do get too hot and your system doesn't recognize it, the high limits will kick off the unit and lets us know, hey, there's a problem. So then we start diagnosing why this high limit going off. So that's when we start diagnosing the heat strip. Maybe it's pushing off too heat, breaker's going bad. Just gotta wait now, let the heat just rise up, let the temperature split do its thing. Then we let us know, here's our wet bulb, our humidity, our dew point. And you usually want that range to be about 20 to 35 during winter time. So we got 66 degree air coming in, about 85 coming out. Like I said, we just now put them in, so it's gonna take a little bit to kind of run them properly. So your delta T right here is at the bottom. All it is just a difference between your supply and return. So it's the hot air that's pushing out, and the return dry bulb is the air that's sucking in. So usually you want that in winter time, you want it to be about 20 to 35 degree difference, and that's what the delta T is on the probe here. It's just the difference between the supply and return dry bulb. Just got done preventive maintenance on this air handler. We always recommend getting your heat checked once a year. Oklahoma weather is very scary. Ice storms, cold weather, high winds. So getting your heat check definitely takes care of you, so you have the peace of mind that you won't be going in without heat.